Okay, tomorrow we're going to review three-dimensional figures. So I definitely would have them say three-dimensional. And then here I am with polygon, dear gosh. So, no, the word is three-dimensional. Yes, we want to write the whole thing. But then off to the side they can write 3D. So fix that, my bad. So three-dimensional. Attributes. Do y'all remember what attributes is from yesterday? If I say to list the attributes of the figure, what am I saying? Yes, I'm saying describe it. Do you remember an even better word? Like if I say list the attributes, I want you to list the specific, yes, it's characteristics. So that's a big one, attributes. Can y'all tell me the attributes of a polygon? Yep, and then review from yesterday. Ask them for the attributes of a trapezoid. So always, tie in some stuff from the day before to review. If it were me, I probably would even be on the back of the paper, like, if I drew a trapezoid, what are some of its attributes? Okay, it's four-sided. What's something better than that? Ah, it's a quadrilateral, and okay, what else? What's another attribute? It is a polygon. How do you know? Yep, because it's flat, straight-edged, closed. Oh, okay, one of the biggest attributes, yes, it has one pair of parallel sides or edges. We could prove it. Parallel, like a pair of L's, side by side, like these pair of L's. So you could do some review. All right, what shape is this? Square. What shape is this one? This is the rhombus. What attribute do they share? Yeah, they're both quadrilaterals. Quad meaning they have four. Good, Landon. Four edges or four vertices. What's another attribute that these guys share? Yes, they have four congruent edges. Same size, same shape. What's a unique attribute that the square has that the rhombus does not? Squares not only have four congruent edges, but they have right angles. That's what makes them a square. And why are they not a trapezoid? It's because they have two pair of parallel edges. If you're parallelogram. So you could do a little bit of review and then come back to attributes. So if you're three-dimensional, you are 3D because you have three measurable dimensions. A 3D object, we can measure its length, width, and they pop because they have height. All right, so some examples. Well, here's some right here. Prism versus pyramid. They need to understand that prisms have two opposite bases and rectangular faces. I always remembered prisms because they were like long, but two opposite bases, like you have this face and then the one on the back. So opposite faces and they're rectangles. Is a square a rectangle? Yes, a square is a rectangle. Why? Because a square has the same attributes. Rectangles say we're parallelograms and squares go me too. Parallel. Rectangles say we're quadrilaterals. Square says me too. Rectangle goes, oh yeah, I have four right angles. And square goes, me too. Squares are rectangles. Pyramid, I always remembered a pyramid because it went up to one point. I mean, that to me is how I knew I had a pyramid. Plus, it has one base. And pyramids have the triangular faces. But, I mean, they need to know the difference. Some examples. Let's draw our own cube. So, this is just kind of showing them how to draw some 3D. So, draw a square. And then draw another square in the top right corner. And then connect these vertices. And you've got length, you've got width, and you've got height. 3 measurable dimensions. To draw a rectangular prism, draw a rectangle. And then in that top right corner, draw another rectangle. Try to be congruent. And then connect vertex to vertex, vertex to vertex. And then, we could draw the cone, like an ice cream cone. Cylinder. I like to try to draw them sometimes horizontal in a different direction. We could draw a pyramid. I always drew, I'm trying to think how I did the pyramid. Depends on what kind of pyramid you want to draw. Doesn't really matter. I think I always did the square, and then I did a point. Yep, a vertex. That's what I did. There you go. Kind of. Just kind of showing them how to make their own. These are 3-dimensional. Why? Because they have length, they have width, they have height. What is not 3-dimensional? Yep, an oval, a rectangle, triangles. Yeah, because all they have is length and width. All right, let's go back and identify faces, edges, and vertices. So what would this, first of all, would this be a prism or a pyramid? A prism, how do you know? Well, you could look back here. Well, it's got 2 opposite bases. You've got this and that one in the back. Or I could say, well, it has a rectangular face. True. What kind of prism? Well, look at its base shape. The bases are triangles. So this is a triangular prism. Tri, as in 3. A-N-G, ular, prism. Faces, I like to kind of point to them. You got 1, 2, this one is 3, 4, and then the bottom would make, so it's 1, 2, 3, 4, 5. Faces are kind of hard. You kind of have to talk them. Edges, I would highlight. So let's trace and count. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's point vertices and count. It doesn't matter what vertice you're on. If we're finding them together, we should end up with the same. 2, 3, 4, 5, 6. All right. Is this a prism or a pyramid? How do you know it's a pyramid? Comes up to 1 point. Good. It has 1 base. Good. Or it has triangular faces. And because the base is a triangle, it is a triangular pyramid. Faces. Well, triangular, you're going to have 1, 2, the back would make 3, and the bottom would make 4. All right, let's find vertices, the corners where edges connect. 1, 2, 3, 4 vertices. And by the way, you could connect that 1 is called a vertex. And then let's trace edges and count. 1, 2, 3, 4, 5, 6. Oop. All right, what shape is this? A sphere, S-P-H-E-R-E. Very good, Lennon. Faces, how many faces does a sphere have?
None.
0, because faces are flat. Because this is like a globe or like a beach ball, because it's circular in nature, you don't have a flat face. Edges. Well, if you don't have a flat face, you don't have any straight edges because edges are straight. How many points do you have? None, because a vertex is where 2 edges connect. All right, go, and then you go to the next page. Prism or pyramid? Prism, how do you know? Well, it's got 2 opposite faces, 2 opposite bases, and then look, rectangular faces. It is a rectangular prism. And of course, I usually break down the spelling with them, like rec, R-E-C, tang, T-A-N-G, uler. All right, faces. Well, you've got front and back, top and bottom, side and side. So we've got 6. This is when you could grab a tissue box and touch. Let's count vertices. 1, y'all should be dotting them as we count. 2, 3, 4, 5, 6, 7, 8. Oops, I wrote it in the wrong spot. Let's trace edges. Everyone should be doing it at the same time and count out loud. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Then I could say, Kevin, do you think this is a prism or a pyramid? Okay, he says a pyramid. What do you think, Owen? Is he right? How do you know he's right? Yeah, he's right because it comes to one point and it has one base and its faces are triangles. What kind of pyramid? Well, you name pyramids by their base. This is a square pyramid. Faces, well, squares have 4 on the bottom, right? That means you've got 1, 2, 3, 4 coming around, and then the bottom makes 5. Edges, 1, 2, 3, 4, 5, 6, 7. Vertices, 1, 2, 3, 4, 5. All right, what's this next shape? Cylinder, yep, it's like a can of green beans. Faces, does it have flat faces or bases? Yes, it does. How many? 2. Because this is circular, it rolls around like a can of biscuits. So we've got 2. Edges, does it have 2 edges? You might hear yes and no. We'll talk about it. It looks like these are edges, right? Straight edges, except that on paper it looks that way. But then go grab something in your room like a cup, This is a cylinder shape. Well, on paper it looks like flat, but are there any straight edges? No. Why? Because it is circular in nature. And if you do not have edges, then you don't have any vertices connecting. All right? I say that. There are no connecting vertices there. All right, what is this shape, everyone? Cone, like an ice cream cone. All right, and does it have any faces? Yes, 1. It has a circular base. Does it have any straight edges? No, it looks like it does, right? But these are not straight. They are circular. But it does have one vertice because these circulars kind of come to one point. All right, and then questions. Read this together, class. Which shape has more vertices? So what are we looking for? Shape. Which shape? More vertices. Good. Pixie, what are the vertices? Pixie. Pixie, speak.
Speak.
Speak. Speak. Speak. Pixie, speak. Do you want a bone? Speak. Yeah, you better speak now. Pixie, you want a snack? Speak. Speak. She's being super lazy. Forget her. Pixie. Pixie, speak. Speak. Do you want a bone? Yeah, I thought so. Do you want a bone? Speak. Speak. Pixie Pug, speak. She's a loser dog today. All right, Pixie, what are vertices? She says where 2 edges connect and make corners or points. Good, so let's count. 1, 2, 3, 4, 5, 6, 7, 8. Label. All right, go to your, what is this? Square pyramid. Good. Square coming to a pyramid. 1, 2, 3, 4, 5. I love how it says rectangular pyramid. Why? Well, because a square is a rectangle. Never heard of a rectangular pyramid, though, but whatever. Which one has more vertices? Rectangular prism. Butching. All right, girls, read us the next question. Blah, 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 blah. All right, what are we looking for? Combined edges, both figures. All right, well, if you combine your fingers or combine hands, what are we doing? Yeah, we're putting them together. So it's like a part plus a part. Where are the edges, Karen? Yeah, they're the straight edges. So let's count. Here we go. Highlight and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Label. All right, go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm like, did I get them all? It's hard to, I think 14. It's hard for me to tell. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. Combine, what does that mean? Put them together. 15 plus 12 is 27. Watching. Boys, read the next one. Blah, 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 say the boys. All right, what are we looking for? Difference between what? Vertices. All right. First figure compared to second. So I want the difference between this guy's vertices and this guy's. If you want to know what's different, it's like saying how many more are here than here. How much greater is that than that? So this is that versus that dun, dun, dun. A difference is the answer to subtraction. And let's get our vertices. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over here, vertices. 1, 2, 3, 4, 5, 6, 7. 12 compared to 7. Well, the difference is that 12 is 5 more than 7. Or 7 is 5 less than 12.